Differentiation from first principles. Now, there are lots of videos on this already, so I'm not going to reinvent the wheel, but I'm going to show you what I think is a safe way to deal with complicated algebra when you're solving these problems. So this video is specifically what I would call a method to avoid algebraic slip-ups. It's how I think you should set them out at A level. So we're going to look at two examples, just these two, and we're going to use the formula in the formula sheet, which is there. So the first one. The trick is, before you go near the formula, is to first work out and expand this particular term here, f of x plus h. Once you've got that expanded and fully simplified, only then should you go near this whole formula at large. So let's consider f of x plus h. Well, one way of thinking about what this means is go back to the original formula for f of x and think of x as thing instead, or input. F of thing is thing cubed, or f of input equals input cubed. So if the input is now x plus h, then the right-hand side of this equation is input cubed, which is x plus h, all cubed. We need to do a binomial expansion to expand that. Don't be tempted to expand it in any other way. Use binomial expansion. So I like to do it this way in column method, which is first to write out the sequence of binomial coefficients, and then do a column where the first term's powers decrease one by one, and then do a column where the second term's powers increase one by one from 0. You'll see that I've sort of blanked out the power zeros because effectively those are just equal to 1. But it's nice to have them there as well. And then we're adding up each of these rows, as each row is a product, and we add up the 4 rows to get our final answer, which we can write like that. And you can check that, for example, the second row here, 3 times x squared times h is there, etc. So we've expanded that term now fully. Great. Now we can go to our formula. So this is now our version of this whole formula with this result that we've separately calculated fed in. So first, the first term up here is our purple result. There we are. But then don't forget we need to subtract f of x. Well, f of x is just this thing here, x cubed. So take that away. And then we're dividing all of that by h. But before we do that, you should find that anything without an h in, any term without an h in the numerator should cancel. If it doesn't, you've done it wrong. Start again or go back and look for your problem. Okay, you have to have anything without an h in has to cancel. Now we can divide by h. Now the temptation at this point is to cancel the h's as well. But don't do that here, because remember, when you write this out for your examiner, the examiner needs to see that you've done this in a nice, logical, sequential way. So don't cancel the h's out in the same step. Rewrite out what you've got left after those red terms have been cancelled, and now you can go through and cancel your h's. Brilliant. One final writing out of the expression that we're now left with, and only then can you let h tend to 0 and simply write down what the answer is. Okay, if you've put this lim notation in here and here and here, you don't need to write explicitly as h tends to 0, because that's already captured here. You've already done that. But if you haven't got this notation here, here, or here, then you can't just say that this expression here is equal to 3x squared. You'll have to then write it up here as h tends to 0, or now let h tend to 0, and then the answer is this. But I think what you can see in front of you there is the best way to set out a problem like that. Right, let's move on to the final example, which is this slightly more complicated expression. Once again, following the same guidance, we're first going to work out this term here, f of x plus h. So first write down what that actually means. So f of input is input to the power 4 minus 3 times input, just as it is here. Right, well, because this is more complicated, I'm actually going to break this down even further. I'm just going to look at this term here and do a binomial expansion of that to begin with. So following again the same guidance, binomial coefficients column, x with descending powers as a column, h with ascending powers as a column, and then we're going to add up each row being a product, and that gives us this full binomial expansion. Now, let's go back to our purple formula. And that's not complete yet. All I've written there is this term expanded. X plus h to the power 4 is just all of this, which we got, which is the same as the red expression here. Then we need to subtract 3 times x plus h. So let's just write that in there. Now, just because I can, it's very easy to get rid of these brackets just in line. So I'm just going to write that as minus 3x minus 3h. Okay, brilliant. We've completed our and fully simplified our purple expression, our f of x plus h. Now it's time to go near this formula. Now I'm just going to clear a bit of space. Just rewrite out that f of x plus h at the top of our screen. There we go. Okay, our formula then. We're going to copy this whole line here, which is f of x plus h first. Then we need to subtract f of x, which is this bit here. Okay, and again I'm going to tidy up the brackets just in situ there, so we don't have to write the whole thing out again. There we go. And remember, we need to be able to cancel, in this line we need to cancel anything in the numerator which doesn't have an h in, and you should again find that that works perfectly. There we go, they all cancel nicely. If they don't, you have to go back and find your mistake, because that will happen. Okay, rewrite it out again, even though it's a bit of a faff. This step is where you cancel your h's. Rewrite it out one more time, just remaining what's left in the numerator. And then your last step is just where you simply write down any term that's remaining without an h in, because you're letting h tend to 0, which will eliminate these 3 terms here, because they've got h's in, which becomes 0. And that's it. How do you know you've got the answer right? Well, you know how to differentiate stuff, don't you? You know what f dash x is. You can look at this and just write down 4x cubed minus 3, because you're an expert already at differentiating polynomial expressions. So if you're not getting what you know the answer is down here, then go back and find your mistake. Thank you.